I guess we're live. So usually we give it like a
Okay.
couple of minutes for people to join. I think it's sometimes you get this notification. So if you have like the app on your mobile, basically you get like a notification that Hazelcast is live now. If not, maybe you get an email or using laptop. So usually it takes like 3 to 5 minutes when we go live for anyone who wants to join. But I guess now we have some viewers. So I think we can start. So welcome everyone for our weekly live stream on Twitch. Joining me today, Metin Dumanda, to talk about the compact serialization. So welcome, Metin. How are you today?
Well, thanks. I'm good. How are you?
Yes, I'm good. I think it will be great if we can just start like a little bit background about yourself. What do you do at Hazelcast? And then I hand it over to you for the presentation and the code.
Okay, sure. So I joined Hazelcast as an intern like almost 5 years ago after my second year in the university. After doing my internship here, I worked as a part-time software developer in the client's team for 2 years. Back then, I was mainly working with the Python client. And after graduation, I became full-time software engineer, again in the client's team. And during the last 2.5 years, for some time, I was working with the Node.js client as well, but most of my time, I guess, in the last years was spent with the Java client. I was also in part of the work around this binary protocol for the client-to-member communication, basically, and these new serialization formats. So these days, I'm just mainly working on the Java client, but time to time helping things related to Python client as well for reviews or some small tasks.
Yeah, I think this is great to hear. So I think the main discussion today is for the compact serialization. So for anyone who is watching now or later on YouTube, if you have any question, I think you're available on the Slack community if they have any question. And obviously the also source code is on GitHub. So if they have anything they want to ask about. So with that being said, I will just hand it over to you if you want to start the presentation.
Okay. Let me close my camera as well, just to upload the presentation pretty smoothly. So, yeah, you can see it, right?
Yes.
Okay, great. So we will be talking about compact serialization today. So first of all, what is serialization? So Hazelcast basically provides you access to distributed data structures, and most common of them is a thing called map, like a dictionary or map. So for example, when you do map.put with a key and value, if your key and value are simple objects like strings or integers, Hazelcast client and server knows how to serialize or deserialize it, basically converting it to byte array representation. So there is no problem with that. You can use such simple types out of the box without any configuration or any change. But if you want to use your custom types, your custom classes, there is a problem because Hazelcast needs to know how to serialize those. And without any configuration, it's hard to know. So you need to pick a serialization mechanism for such use cases. So there are lots of existing serialization libraries, and there is a high chance that you as a user are using one of those. It's like protobuf, avro, captain proto, flat buffers, flex buffers. And honestly, you can use those serialization libraries with Hazelcast as well. So you can use those libraries to convert your classes into byte array representation and use those byte arrays as your keys or values in your map. So that would work without any problems, but that's not good in one term. So when you do that, Hazelcast cannot reason about your data, cannot understand what your data is. It's from the point of view of the Hazelcast server, it's just a plain byte array. It doesn't know anything about it. So if you are going to use Hazelcast as just a cache or just as a data source, well, you do just map.puts and gets, that's fine. But Hazelcast is much more than that. So it has an SQL, like it has a query engine with an SQL front end. It also has Jet, where you can manipulate your data in every imaginable way. Let me say that. as a stream processing tool. So there is a lot of capabilities of the Hazelcast, and to use them fully, you have to use some specific Hazelcast specific serialization mechanisms so that Hazelcast can reason about your data. So compact is one of those serialization mechanisms, but before compact, we had others as well. I will talk about those other serialization methods at the end of this talk. Basically, I will compare them with compact, and I will explain why we need compact while we had those pre-existing serialization methods. So let's start with why we wanted to have a new serialization method, basically. So here were our like basic requirements. The serialization format we need to have should be easy to use so that you can use it pretty easily among your clients in different languages. It should be space efficient, meaning that while storing your data in binary form, it should not incur much overhead. It should not like have repeated metadata or something like that. It should be like as small as an overhead possible. As that was needed. Also, as I said, it should be polyglot friendly. So the same serialization mechanism should work in Java, Python, in Go, Node.js, C++, .NET, everywhere. And it should be open to the class evolution. By class evolution, I mean that your data and your class will change over time, possibly. So you can add new fields or remove some fields or change the types of some fields. Our format should allow that pretty easily. And most importantly, it should be efficient for queries. So it's not just for puts and gets, but when you run SQL queries on top of this new format, it should be fast, basically. So what do we mean by easy to use? So let's assume that you have this very simple Java class with just a single integer field. So what we wanted to achieve is that we wanted not to require you to change the source code of your class in any way. We heard some complaints about that for our other serialization mechanisms. Some were saying that I cannot like change the source code of my class. It's in some different jar, some different module. I cannot change that. And some were saying that like I don't want to pollute my domain classes with your interfaces. So they wanted to not do that. And to achieve that with other old serialization formats, you had to use some ugly ways, like this naive type pattern where you wrap your class in another class and implement our interface on that class, basically from that wrapper class, but it's both inefficient and ugly. So we want to avoid that with this new format. So with this new format, you don't have to change anything in your class. It can stay as it is, and we don't have any requirements for the types of classes you have. Like we don't need you to have some sort of getters or setters or some constructor with, I don't know, all your parameters. It's all up to you. You can use whatever the class you have. What you need to do is to write a thing called compact serializer for your class. The compact serializer is just a tiny interface with 4 methods. Basically, I will explain them. So like after you implement your serializer, you will register it to your configuration. So in your serialization configuration, there's a thing called compact serialization config, and you basically add your serializer to there. And after doing that, you will be able to serialize your instances of this foo class with your serializer. So it's pretty easy to use. So let me talk a bit more about this serializer. Like I said, it has 4 methods. So let's start from top to bottom. So the first method is a thing called read. So it takes a argument called compact reader, and it expects you to return an instance of your class. You can think of this compact reader as a map, basically. It's a map from your field names to your field values. You can think of it like that. And inside of this class, basically what you need to do is to read your fields one by one. The order is not important. You can do it in whatever way you would like. And basically construct an instance of your class out of the fields you read. So like here, you can see that we are using a method called reader.readInt32 with a field name called bar. So what it does is that if there is a field called bar, and if the type of that field is integer int32, it will basically return you the value. So it's like a map lookup. Similarly, we have a method called write. It takes an object called compact writer and instance of your class, like let's say your foo class. So you can think of writer as a dictionary as well, but this time instead of reading from dictionary, we are going to write to the dictionary. So you take your object, you take your writer, and using methods like write int32, you give a field name and a field value. Basically like a putting an entry to a map or dictionary. So you might be wondering, what is the significance of this field name? Honestly, it doesn't have any significance. It's just a string that represents your field. In the upcoming slides, we will see how you can use this compact serialized data in your queries, etc. So you will reference your fields with this field name, basically. So it doesn't have to be the same field name as your object. Here it is the same, like it's called bar in this string field name and your actual field, but it doesn't have to match. You just need to remember that whatever you call your field with this field name, you will use that basically to access your field in queries or other places. The other method is called getTypeName. It's an important method. It's basically a unique string that represents your class. The uniqueness should be provided by you, so you need to be careful by like not using the same name for different classes. We basically, behind the scenes, you will use this type name to match different serializers. So in the upcoming slides, I will be talking about schema evolution and serializer evolution. So you will be using this type name to match those evolved serializers or evolved classes. So it's an important one. And the last method is called getCompactClass. It's a very simple method that just returns the class of your, like the class instance of your class, basically, so that when you do that, we can basically understand that you want to serialize instances of this foo class with this serializer. So we basically do the matching for you once you provide us the class. So as you can see, there's nothing you need to do for the class. You just introduce a totally new class that implements a special interface and register it in your configuration. After doing that, you can use it basically without extra operations. There is also another very good thing called zero configuration only for Java, only for our Java and .NET clients. So basically, what it does is that when you do not register a serializer for your class, you don't write a serializer for your class, you just do nothing. You have this class and you have, like, you call map.put with an instance of this class. In that case, in Java and .NET clients, we will try to we will try to write a serializer for you on the runtime. We will be using reflection to read your fields, read the field names, field types, and basically try to write something like this in the runtime. So it has, of course, some limitations, but it's pretty usable. We have documented these limitations in our reference manual. You can take a look at there and see those limitations. But one very important thing with this zero configuration is that although you can use it without any configuration and it sounds very easy and useful, it has some overhead. So basically, we are extracting your schema or serializer in the runtime using reflection. And on top of that, we continue using reflection to read and write your fields via serializing or deserializing your class. So it has some overhead, and I would say that overhead is pretty considerable. Of course, I cannot give an exact number because it changes from class to class, but you need to measure it. But I can assure you there will be some overhead. So what I recommend is that you can use this zero configuration to play with Hazelcast. Basically, you have your class, you do nothing, you call map.putGet. You can do that. You can run SQL queries on top of it. But once you go to the production, I will suggest you to write an explicit serializer like this and register it. This way, it will be much easier to evolve your class, evolve your serializer, and you will have much control over your serialization process, and it will be more performant. One extra note with zero configuration in Java and .NET is that they are not interoperable, meaning that if you were to write an explicit serializer like this in Java and .NET, they can work together. But for zero config, we are doing something special in different languages. Basically, they cannot work together. So Java will work with Java, .NET will work with .NET, but you cannot like write from Java and read from .NET with zero config. But you can do it with explicit serializers. So just a note about that. Another requirement of our new format was that it must be space efficient. So when you take a look at the binary blob, basically we wanted to store as much as the data itself without an extra overhead. So some of our pre-existing formats like portable was self-describing. So it contains metadata per object. So we did not want to have such an overhead for the new format. We want to have just a tiny, very small, like an identifier for a schema. And instead of duplicating this schema in every object, we will store it in some central place, and we will refer it to this schema ID, and we will avoid like lots of metadata overhead per entry, basically. When you think about that, like the portable has actually quite an overhead on that regard. So when you think about that, when you have like millions of instances of portables, the overhead of this metadata can be considerable. So we wanted to avoid that with Compact, basically. You might be wondering about what is this schema is. We didn't talk about that while talking about this serializer. Schema is basically a thing we extract automatically from your serializer. We extract it from the write method of your serializer, basically, automatically behind the scenes. You don't need to do anything special about it. It is also replicated and distributed automatically by the client and the server. So you don't deal with any of this ugly stuff. There are lots of edge cases. So we take the burden out of you and implement it in our clients and servers. Basically, schema is just schema is basically a thing that describes your data. It has like a field names and field types, and it divides the fields into two categories, like fixed size types and variable size types. We will see how they are useful while talking about queries. And it also contains information about the positions of some fields. We will see how they are useful in the upcoming slides, basically. Another requirement was that we needed to be polyglot friendly. So we needed to provide the same API in all of our clients. We have clients in Java, Python, C++, .NET, Node.js, and Go. And Compact is going to work in every one of them in an interoperable way once you use like explicit serializers, not the zero config. And one extra nice thing is that think like that you are a Python client user. You don't need to do anything special on the server. You don't need to write a serializer and register it on your server. You can just use, let's say you are a Python client user, you have a class in Python called foo, same one with the Java. You write your serializer in Python. You can use just the Python client to get a map. You can put your instances of this foo class. You can get them. You can run SQL queries on top of them. And like I said, you don't have to do anything special on the server. You can just start the server using Docker without any configuration. And all of these things will work out of the box. That's what we meant and needed by this polyglot friendliness, basically. And another thing is that the class evolution. So when you think about the long term, it's quite obvious that you will need some new fields, or you need to remove some fields, or you need to change types of some fields for your classes. And our new format should be open to that, and it should provide ways to preserve backward and forward compatibility, meaning that your new readers or new writers can work with old writers or old readers, or vice versa. And different versions of your data, like ones written by old writers and ones written by new writers, can live in the same map. And one very important thing is that it should be as easy as possible. You don't need to manage versions manually by hand. It was like that in Portable, one of those pre-existing serialization mechanisms, and we wanted to avoid that. So let's continue with the Python sample. So here on the left, you see the old version of your class. Let's say you add the new. So it had a single integer field. Now let's say we have added a string field to that. So let's go over what changes we need to do in our classes and in our serializers. So in your class, you don't need to do anything special. You just add your new field as you wish, and we don't really care about that. The magic happens on the serializer. So remember, we had the 4 methods. You don't need to change this get type name or get class method in any way. They should stay the same. So you are still writing a serializer for your foo class here, and for the type name, you should continue using the same type name so that our implementation can see that, yeah, this foo serializer, the old foo serializer and this new foo serializer are for the same class. So we will do the matching using this type name. So it's important that you use the same type name, even if your serializer is, or your class is evolved. In the write method, you don't need to do anything special as well. You just continue writing all of your fields with the correct types and your preferred field names. Basically, the order of the fields is not important. You can write it in any way. We will handle all the things behind the scenes for you. You just write it as you wish. But the only thing you need to be careful about is this read method. So we basically have 2 types of fields, ones that are required and ones that are optional. So when you think about that, this bar field is a required one because you try to directly read it. So when you take a look at this old serializer, it doesn't do any if checks or anything. It just tries to read that field. When it cannot find a field called bar with the type of int32, this serializer will basically fail. So what you need to be careful about is that you cannot remove such fields without breaking compatibility, basically. But you have added a new field. So how you do that? So basically, we provide you an API called getFieldKind that takes a field name and returns the type of the field. So in your new serializer, what you will need to do is that you first need to check if there is a field called pass with the string type. If there is, we know that it's written by a new writer so that we can read that field. If not, we can use some sort of default value as you wish. You can write it as you wish. So when you think about that, since the old reader does not know anything about this new field, it will simply ignore that. So it will work. When you think about the new reader, it will perform a check to see if the field is there before attempting to read it. So it will work as well. So this way you can preserve backward and forward compatibility between the evolved version of your serializers. So just be careful, and if you add a new field, make sure that you are using it with a pattern like this, and make sure that you do not remove any fields that are not part of this pattern. So you cannot remove this bar field without breaking compatibility, basically. Another requirement for our format was that it should be efficient for queries. What do we mean by efficient? So in this foo class, you had 2 fields, but let's say you have added another 10 fields. Now you have 12 fields. And you want to write a query, you want to run a SQL query like this. So you will like read basically 2 fields. You will check the value of this bar field, and you will select the value of this bus field. So without partial deserialization, you would need to deserialize the whole object with all of the 12 fields, even to like just access 2 fields. But with partial deserialization, you can just access whatever you need. So the server is smart about reason about that and just extract the necessary information in queries so that it doesn't have to perform a costly deserialization. It also, like this new format, needs also provide ways for fast lookups. I will talk about them in the next slides. So let's see how our NIF compact format provides fast lookups. So on the left, you see basically a serialized version of your class with 12 fields. Let's say it looks like this. So on the first few bytes, there is a schema ID. There's an 8 bytes long schema ID. Then there is some extra data. Then there comes your bar field, and then there's some data for your other fields, and then there comes this bus field, and then there's some extra data, and then we have a section called offsets. I will talk about offsets in the next slide. So if you remember, I said that schema basically divides the fields into 2 categories, fixed size fields and variable size fields. Like integers are fixed size fields, so we can know exact offsets of such fixed size fields from the schema. We can basically like take a look at your write method of your serializer, extract fixed size fields, sort them in a deterministic algorithm, and like determine offsets directly from the schema. So with that, like when we try to read a fixed size field, we will just do a single lookup from the schema. We will get the actual offset, and we will go there and basically read that field with just a single lookup without deserializing the whole object. As you remember, we have the schema ID and we have this schema in a different central location, so we can refer to that. For fields that are variable size, there should be another indirection basically, because their size are not known in the schema. We cannot know the size of like variable size fields. So if you think about that, there could be some field before this bus field in different versions of data. And in some data, it might be 10 bytes long. In some data, it might be 100 bytes long. So we needed another indirection so that we can determine the exact offsets of variable size fields as well. And we still use schema for this. Like when we try to read a variable size field, basically we ask the schema to provide us the index of this variable size fields in the offsets section, basically in this section. And after reading the index of the offsets, we go to the offsets. You can think of offsets as like an array of offsets of the variable size fields. So after getting the correct index, we go to the offsets section, read the actual offset of the field, of the variable size field, and then we go to that offset and read the field. So in variable size fields, there is basically 2 lookups, let's say, compared to fixed size fields. That's like basically all I need. I plan to talk about the compact serialization and some internal implementation details of it. So let's talk about the supported types with this format. So we basically support things like Boolean and signed integers and floating point numbers, basically all primitive numbers, not unsigned ones. We also support nullable versions of these primitive types, so nullable Booleans, nullable signed integers, etc. We support strings. We support an arbitrary precision decimal numbers. For date-related classes, we support date, time, timestamp with time zone. We also support nested compact objects. So like when you think about that, you can have another object within an object which is also a compact. And we also support arrays of these types above. For the exact mapping between these types and the types in our client languages, you can take a look at our reference manual. We have a table there showing all the details about these type mappings. But like we basically support lots of types, and we believe that it will be enough to cover most of the use cases. These types also selected to be compatible with our SQL subsystem as well. So whatever the columns you have in our SQL, yeah, you can find an equivalent type in compact implementation so that you can like write queries basically. While talking about SQL support, let's show what you need to do to like start creating compact serialized objects. So in Hazelcast, before you start querying anything, you need to create a mapping for your maps, basically. Mapping is just a thing that describes the schema of the map, let's say. It describes the fields and the types. So let's say you have a map called MyMap with compact keys and values. So the key is a compact object with type name person ID. It has a single field called ID with an integer type. And the value is another compact object with type name person. It has fields like name, surname, and age. So basically you describe these columns, your schema of your map, and you execute this once per your map before start querying your data. After doing that, you can take like, you can use the SQL basically fully. You can do anything we support. The compact will work. Another nice thing about compact is that we also support generic record representation. Generic record is a feature that allows you to access portable and compact serialized data without having the class or serializer in your class map. So let's say you have written an object of class foo from Python client, but you don't have an equivalent class in your Java client. You can use generic records to basically like access individual fields of your data, even though you don't have any class. So you can also write, basically, you can create generic records by giving the type names and field values. And you can also read individual fields with generic records. It's quite useful when you don't have the class in your hand, but you still want to access your data. It can come handy, and it's supported by the compact serialization. And we also fully integrated this compact serialization into Hazelcast. So we have the out-of-the-box support for WAN replication, hot restart persistence, etc. We are also working on a code generator, something similar to protobuf compiler or Captain Proto compiler, basically taking a schema file and that generates a serializer in different client languages automatically. We think that it will simplify polyglot use cases more. Once you have a single schema file, you will be able to generate serializers in whatever the client you would like without writing anything, basically. We believe it will be nice. We are still working on it, not released yet, but hopefully it will be released soon. Okay, so let's do this comparison as the final thing. So before comparing compact serialization to any other form, any other pre-existing format we have, I would like to remind you that if you are new to Hazelcast, or if you are not sure what serialization format to use, you should use compact. It will fit nicely into most of the use cases, and it will offer great performance with almost no overhead in the serialized form. So it's like as good as it gets. Of course, like our other serialization formats are not useless. They have they have trade-offs. For certain use cases, they might be better than compact, but like if you are not sure, if you are new, you should just use compact, and it will be good. It will be mostly good for almost all the use cases. So let's talk about this identified serialization. So you can think of identified as just a concatenation of one field after another. So there is no metadata, there is no offsets, there is no nothing. It's just byte array of concatenated fields. So the not so nice things about identified is that it does not support partial deserialization. It does not support class evolution, so you cannot add or remove fields. It also requires you to register a serializer in serializer in the server. Basically, if you're like a Python client user, you need to still write a Java identified serializer and register it on your server to run queries on top of identified objects. And it requires your class to implement a particular interface. But the good thing about identified is that like it's as compact as possible. It's just like fields one after another without any metadata. So we use identified quite intensively in our member-to-member and client-to-member communication, basically. So if you don't need like partial deserialization, you don't write queries, or your objects are very small so that the partial deserialization does not have any effect, you might consider using identified, but like the lack of support for class evolution could bite you in the long term. So I would like suggest not using it and stick with compact. Portable is another format we have. It supports partial deserialization, so it's good for queries, but it's a bit slower for lookups of the fixed size fields compared to compact. For variable sized fields, it should incur the same cost, so it should be equivalent. The not so nice thing about portable is that it stores the schema per entry. So like if you have millions of entries, you will have millions of schemas instead of a single schema. So it incurs a considerable overhead, so you might want to avoid it. It also supports class evolution, but the evolution management is manual. So you need to basically tag your versions manually by implementing a special interface and giving manual versions. It can be ugly to do it manually. It also requires you to implement a particular interface. So that's like identified, not like compact. The good thing is that you don't need to register anything on the server for queries as well. So if you are a Python client user, you can just use it without anything on the server side, anything Java code, basically. Another method we have is that like HazelcastJsonValue, we call it like that. It's basically a very thin wrapper around the JSON serialized strings. So I would say if you are working with JSON data a lot, it might make sense to use it, but it doesn't have any concept of schema, so you need to take care of everything. It also supports partial deserialization, and it has support for some metadata creation on write. So we can extract some metadata when you write HazelcastJsonValue objects to determine the positions of fields, but it's like a portable in that regard. So it's like stores and metadata per object, which can be costly. So like if you're not like fully using JSONs with like no schema with very different kinds of JSON values, I would avoid using that and stick with compact as well. So as you can see, like we believe compact serialization is a pretty good alternative to the existing serialization formats we have. It's not the only solution for every use case, so you still need to do measurements, like take a look at your use cases to determine exactly what you need to use. But like directly using compact might be a good bet. It will mostly work very fine for use case. So yeah, that was basically all the things I would like to talk about our compact serialization. So I can take any questions if there are.
Yes, thanks, Metin. I think this is really useful introduction to compact serialization. We got a couple of questions here. So in terms of performance, can you just explain the situation for zero config when it comes to performance? Why it's not recommended?
So basically, like I said, for example, when talking about Java, we use reflection to write and read your fields. So when you think about this explicit serializer, instead of like calling methods directly, like instead of like calling object that get bar directly, we are using reflection to access that field, and that has a cost. So it depends on how many fields you have, but I would say that you can expect like a almost 2x performance improvement when you switch from zero config to explicit serializer. So it's that overhead. So like I said, I cannot give an exact number. It will change from class to class. You need to measure it basically. But like I said, it's good for playing out with the Hazelcast, but for production use cases, we basically recommend an explicit serializer.
Yes, that's great. Thank you. And in terms of the one support and persistent support, can you just comment on it?
Sure. So by these support, I mean, so I said that we extract the schema out of your serializer and distribute and replicate it basically behind the scenes. So by support, I mean that we will, for example, let's say you have a WAN cluster consisting of like, let's say multiple clusters. Say you write a compact serialized data into one of the clusters. While replicating your data to another clusters, you will replicate your schemas in efficient way so that when you try to access that data in the second cluster, you will find the schema. Basically, by support, I mean that the same thing goes for hot restart. So we like when you enable persistence for your maps, while serializing your compact serialized data, we also serialize your schema, but we don't do it like portable way. We still store the schema once, even if you have like millions of objects or in persistent data. So we basically integrated this schema replication and schema management thing into these areas.
Yes, that's great. And in terms of future updates on the compact serialization in the next release?
We believe that the compact will stay stable. Like we don't expect to add too many new features to it. We believe it's in a pretty good shape. We will try to enhance the compact serialization usability by like writing a code generator that generates serializers automatically. Basically, we will possibly be working on these areas. We will, of course, be taking a look at the performance aspect. If there are things that we see we can improve the performance of compact, we will definitely work on those areas. But I would say that there is no new features planned in the short term. There were some ideas of adding unsigned integer types to the system as well, but we don't, like I said, we don't have near-term plans for it. Maybe we can add it if there are enough requests from the community.
Yes, thank you. So speaking about the community, I think if anyone has any question about the compact serialization, feel free to reach out to our Slack community and basically leave your questions over there. And also, I believe the code is in GitHub. Is that correct, Metin?
Yes, it's fully open source. The implementation of all the server-side code and the client-side code is in the GitHub.
Yeah, so if anyone would like to contribute to the code, feel free to do so. With that being said, thanks very much, Metin, for your time and for your presentation. I think this is really useful for the community to start using the compact serialization, especially as first choice, as you mentioned. But obviously, when it comes like comparing different serialization methods, I think it's important just to check before. So thanks very much for your time and for your presentation. For anyone else joining us now, feel free to leave any question on our Slack community channel. This video will be live on YouTube as well after we finish here, so you can and basically you have the option to watch it later on YouTube. So thanks very much, Metin, for your time.
Thanks
See you next
everyone for listening. Have a nice day. Bye.
time.